Okay. So section 2.4, we're writing equations of lines. And there's a lot of different equations of lines that we have that we learned about in Algebra 1. We're not going to go over all of those. We're just going to focus on slope-intercept form, which is the main one, the one we focused on the most in Algebra 1. It's also probably the easiest and the most common. So what is slope-intercept form? Y equals mx plus b. And to write the equation of a line in slope-intercept form, you always need two things. You need m and you need b, right? You always need m and b. And if you have m and b, you can write your equation of a line. So we're going to start out simple. They're going to tell us we have a slope that goes, or a certain slope going through a certain point, and we want the equation for that specific line. So, what two things do we need? I have them highlighted to get the equation of a line. What two things do we need?
The slope and the y-intercept.
We need slope and y-intercept. So, in problem A, they want us to go through the point 54 and have a slope of negative 3. Did they give us any of that information that we need? What do they not give us?
They ain't giving us the slope. What do you mean?
Well, they gave us m, didn't they?
Well, I mean, not the I ain't giving the y-intercept.
Yeah, they gave us the slope. M is slope. So they gave us that part. They did not give us B. So we've got to get B. So what else did they give us, though?
X and y.
Yeah, if they give us a point, they give us X and Y. Okay? So to get the B, we're just going to use the formula y equals mx plus b. And we're going to plug our y coordinate in for y. What is our y coordinate? 4. Our m is negative 3. What's our x? 5 plus b. And then we're just going to solve that for b, and then we'll have b, and then we can write the equation. So what is negative 3 times 5? So 4 equals negative 15 plus b. And then what do we do? Not divide. Add 15 to both sides. And 4 plus 15 is 19. So now do we have m and b? All right, so put it together in the right spot, and we have our equation. Y equals, what's our m? X, and our b is a positive 19, so we say plus 19. So there's our equation of the line that goes through 5, 4 with a slope of negative 3. That's all you have to do. Use y equals mx plus b to get your b, and then plug that into your equation. So any questions about that? Was that easy? Do we need to see another example of that, or can we move on? See one more. Okay. I got you. I got one. This time we're going to go through the point 8, negative 1, and have a slope of a negative 1/2. So we need what two things? And slope and y-intercept. We need m and b. Okay? Do we have m or b? We got m. We need b. So how do we get b?
Put it in. Put y equals negative 1/2.
Well, let me just, okay. Yeah, what goes in for y, though? Yeah, so we got a point. We use our x and y. So negative 1 equals negative 1/2 times 8 plus b. What's negative 1/2 times 8? That's right. It's not too complicated. Half of 8 is 4, and it's going to be negative. So negative 1 equals negative 4 plus b. We're going to add that 4 to both sides. What's negative 1 plus 4? 3. So there's our m. There's our b. So what's our equation? Y equals what? Very good. We good on that? Okay. Next thing we're going to do is use this and talk about parallel and perpendicular lines. So this time we want to go through the point -2, 3, and we want to be parallel to the lines, or to the line y equals -4x plus 1. So we want to go through the point -2, 3, but this time we want to be parallel to the line -4x plus 1. So we're talking about two different lines here. We're talking about the first line goes through this point. We don't know nothing else about it. And then this other line, we have the whole equation for it. Okay, so we want our line to be parallel to this line. Now, what did we say yesterday about parallel lines? They had the same slope and they never intersect, right? But the information we really need right now is that they have the same slope. What's the slope of this second line over here? -4. How do you know -4 is the slope? It's the M, right? It's in the M spot. So their slope is -4. So if we're going to be parallel to that line, what does our slope need to be? -4 also. So you pick out their slope, and if it's going to be parallel, you want your slope to be the same thing. Does that make sense? All right. Now what we do is exactly what we did earlier. We're going to use y equals mx plus b. We'll scroll. And what do we plug in for y? Yep. What goes in for m? -4. What's x? And what's -4 times -2? +8. And now subtract 8 on both sides. And what do we get for b? -5. So I've got m, I've got b. What's this equation?
Y equals -4.
-5, since it's negative. Very good.
Why would you do one?
It's okay. Yeah, because you was looking at this side over here instead of the b. But yeah, when you finish and you have parallel lines, double check and make sure you didn't put something in the wrong spot, because the slopes should be exactly the same. Okay, different y-intercepts, but same slopes. So any questions about parallel lines? Well, what do you think we're going to do now?
Perpendicular.
Yes, we are. Perpendicular. So this time we want to go through -2, 1, and we want to be perpendicular to the line y equals 1/3 x plus 10. Now, it's your notes. It's your notes. I'm not going to read them. All right. So, what's their slope?
1/3.
1/3. So their slope is 1/3. Do perpendicular lines have the same slope? No. What kind of slopes do perpendicular lines have? Opposite reciprocals, right? Opposite reciprocals. So that means we flip it and change the sign. So if we flip it, we get 3/1, which is +3, right? And then we change the sign, that makes it -3. So our slope will be -3. Does everybody understand that? Okay. Flip it and change the sign. And we had to simplify that one. So same thing, we're going to use this point, this slope, and plug them into y equals mx plus b. So what's going in for y? Try
One.
again.
I mean, one. One.
Yeah. And what goes in for x?
Two.
What's negative 3 times negative 2? 6. And subtract 6. 1 minus 6 is what?
5.
Negative 5. So we got m, we got b. What's the equation?
Y equals negative 4.
Just say minus 5, yeah. So perpendicular, make sure you get the opposite reciprocal slope. All right, so you guys are about to try one of each on your own paper. I want to write black. I want you to go through. I'll give you one of each. It says negative 5. I know it's scrunched them up. Negative 1/3 x plus 7. So give me the equation for those in slope-intercept form. And I have made a list of y'all's calculators. Y'all have the bottom sheet of paper, so it tells you which one your number is. Finally got that done. If you got both of them, you can check them with a neighbor. If not, keep on working for a few more minutes. So, what do parallel lines have? Same slope. So what's the slope of the second line? What's their slope on number 1? Their slope is -1/2. So our slope will also be what? Same thing. So you use y equals mx plus b. Your y you should have used was what? 6. M is -1/2. What's your x? Plus b. What's -1/2 times -2?
-3.
Try again. It's +1, right? Subtract 1, and we get 5. So the equation should be y equals -1/2 x plus 5. Raise your hand if you got that right. Any questions about that one? Are we good on parallel? So perpendicular lines have what kind of slopes? Opposite reciprocals. So what's the slope of this line over here? Their slope is -1/3. So our slope needs to be what? Flip it, change the sign.
3. It's a regular 3.
It is just regular 3. We flip it around. That's 3/1. Change the sign. That's +3/1, and 3/1 is 3. Right? 3 makes it a little easier. Does everybody understand that our slope will be 3? We good with that? So y equals mx plus b. So my y is 1, my m is 3, my x is -5. What's 3 times -5? -15. And then I add 15 to each side. 1 plus 15 is, well, you're adding them. 16. So your equation should be y equals. Any questions? All right, that is all of section 2.4. Yeah. So we're skipping section 2.5, and now we're going to go to section 2.6, and it won't take us long to do 2.6 either. We're doing 4, 6, 8. Yeah, we're skipping 5, and we're skipping 7 also. So, yeah. All right. So section 2.6 talks about scatter plots. And again, you only need notebook paper for this one. We're going to do some graphs, but we're just going to jot down little examples. Now, a scatter plot is when you're just collecting data. Okay? So you're collecting data. It doesn't necessarily fit to a graph or a line. Okay? A straight line or a curved line. It doesn't necessarily make a certain shape. That's why it's called a scatter plot, because the data could be scattered all the way around the place. What we do is we try to find a trend in the data. So, for example, we can have a positive trend cause a positive correlation. This might ring a bell. Can you stop, please? We can have a negative correlation. And we can have no correlation. So, if we have a graph of data, and it seems like the trend in it, these are just random points. And if it seems like the trend, I know my dots are really small and faint. I guess I should make them fatter. If the trend in the data looks like it's going upwards from left to right, like if I drew a line through the middle of the data and it would have a positive slope, then that is said to have a positive correlation. So if the data trend looks like it's going upwards from left to right, then we have a positive correlation scatter plot. Ring a bell? Okay. And if it seems to like it's going downward from left to right, like these little dots, they're scattered. They don't really make a straight line. It's not connect the dots. But from left to right, they seem to be going downward. That is said to have a negative correlation. Do y'all know what a no correlation scatter plot looks like? The dots are kind of everywhere. Yeah. The points on the graphs are kind of where you really can't tell if it meant to go up from left to right or down from left to right. They're just kind of all over the place. That is no correlation. So we really couldn't draw a line through the middle of the data and tell what it's going on. That is no correlation. Something we did not talk much about in Algebra 1 is something called the correlation coefficient. Open your book, if you have it, to page 114. Because it would be so much easier to talk about their pictures than me trying to draw them and get us all confused. So open your book to page 114. You got a book, KD? Okay. All right. So a correlation coefficient is a number that is between -1 and +1. So somebody tell me a number that's between -1 and +1. 0. That's halfway between them, right? Then we have a bunch of fractions and decimals that range between those as well, right? Like -1/2 and +1/2, and -1/4 and +1/4. Okay? There's a lot of fractions and decimals that range between those two numbers. Now, if we have a negative correlation, then we will have a negative number correlation coefficient. Okay? And if we have a positive correlation, we will have a positive number for a correlation coefficient. So what do you think we're going to have for our number if we have no correlation? A 0. Okay? So 0 is right in the middle. Okay? It's no correlation. So what you're going to do is they're going to ask you to approximate whether the number for your correlation coefficient is a -1, a -1/2, 0, a +1/2, or a +1. Then if we have a correlation coefficient of a +1, then that means it looks very close to making a straight line, and it's a positive correlation. Okay? Likewise, if we have a correlation coefficient of a -1, that means it looks really close to a straight line, and it has a negative correlation. Does that make sense? Okay. So y'all look with me in the book. That example 2, do y'all see those 3 scatter plots right there in the middle of the page? Well, close to the top of the page on page 114. All right. So look at problem A. Does that look like it has a positive correlation, a negative correlation, or no correlation? Look at it a little bit closer. It looks like it's slightly going down. Y'all see that? Slightly going down. It's not really no correlation, but it's not just a strong negative correlation. So that one kind of has like a weak negative correlation. So I would say that correlation coefficient is about a -0.5. Does that make sense? Because it's not very close to a line. So we would say it's a negative correlation because it looks like it's sort of going down from left to right, but it's not really a no correlation. It's not really a -1. So we'll say it's about -0.5, halfway between. So look at problem B. What would you say?
That's zero.
Yeah, that's no correlation whatsoever, right? It's hard to find a trend in that data. So we would say that one is close to zero. And I'm saying about because we're kind of estimating, right? Now look at C. Does that one have a positive or a negative correlation? Yeah, is it positive or negative though? Positive, and that one looks closer to a line than any of the others, right? So we would say that one is what? Close to which one of those 5 numbers? Yeah, about positive 1. So do y'all understand that? So guess what y'all are going to do? Y'all are going to do those 1, 2, and 3 at the bottom of the page. So y'all try those down there by the guided practice. Do number 1, number 2, number 3. Tell me about what do you think that correlation coefficient is. Either a -1, a -0.5, a 0, a +0.5, or a +1. Okay, so y'all tell me what you think. Do you think, what do y'all think about number 1?
0.5.
Yeah, it's about +0.5, right? Raise your hand if you got that for number 1. Very good. What do y'all think about number 2?
-1.
Very good. It's close to -1 because it's going down and it looks really close to a line. What about number 3?
0.
Yeah, it looks like a no correlation, so that's approximately 0. So any questions on those?
No, ma'am.
Well, that is the end of section 2.6. So now we're going to need out some graph paper. Some graph paper. And we're going to do section 2.8, and that will finish out chapter 2. Oh, goodness, stop it.
Well, we still need the book.
No, you can put your book in the floor. You won't need it till homework time now. Give yourself some space. All right. Section 2.8. All right. On section 2.8, we're going to graph linear inequalities. What's an inequality?
Like negative and negative numbers.
Not negative numbers.
Not negative numbers, negative and positive numbers.
Those are integers. Close.
Ah,
I see where you're going. Another I word.
I feel it hard.
No, we don't say that word number 1. Number 2, you're not.
Okay, I feel smart.
You feel like you did before?
No, you can't call people stupid.
What's your name? It's hard.
All right. So an inequality, remember, is when we have the symbols less than, greater than, less than, or equal, or greater than, or equal to. Inequality means not equals. And so if they're not equals, they're less than, or greater than, less than, or equal, or greater than, or equal to. Right? And we're going to graph them, just like we graph lines. Except for inequalities is not just a line. It's a line and a region called a half plane of solutions. So this should ring a bell from chapter 6 and chapter 7 of Algebra 1. This is where we get to shade and color. We gonna color,
I'm a big boy.
All right. So let's say, for example, we have y is less than or equal to 2x minus 3. So the first thing we want to make sure of is it in slope-intercept form. So if it looks like y equals mx plus b, except for obviously it's not going to have an equal sign because it's an inequality, then it's ready to graph. Another thing we need to go ahead and note is if we have a less than or a greater than, we will use a dotted line. And if we have a less than or equal to or a greater than or equal to, we will use a solid line. So we'll either have a dotted line or a solid line. So this graph, example A, is going to have which one?
Solid.
A solid line. That's right. We'll get there. All right. So draw your X and Y axis. What's our y-intercept? We just did this yesterday.
-3.
So put a point there. What's our slope?
2x over 1.
Which is 2 over 1. So we rise up 2, run to the right 1. And we said we're going to use what kind of line? Solid or dotted?
Solid.
Solid because it says or equal to. So draw, and don't you draw a little short line. Draw a big long line, okay? No little bitty short squatty lines on the shading stuff. Now what that line is right there is a boundary for 2 separate regions called half planes. We got a half plane over here and we got a half plane over here. Okay, so that divided our graph into 2 regions. So either the solutions to this inequality is on this side of this half plane, or they're on this side of the line and this half plane. So we got to find out which area has our solutions in it. The solutions are the ordered pairs that make this inequality true. So what we're going to do is we're going to pick a test point. Now, arithmetically speaking, the easiest numbers to use are 0. So we're going to let 0, 0 be our test point. And you can use 0, 0 for a test point as long as that point is not on your boundary line. So if that point's on our boundary line, we got to pick something else like 1, 1 or 0, 1 or 1, 0. Now to test out that point, remember this is an X and this is a Y. So we're going to plug those in for X and Y to the original inequality problem. 0 is less than or equal to 2 times 0 minus 3. What is 2 times 0?
0.
0. And 0 minus 3 is negative 3. Right?
Yes, ma'am.
So this statement says 0 is less than or equal to negative 3. Is that true or false?
False.
That is false. That's right. So that's really false. So this is not true. So that means none of the points over here are true solutions to this inequality. So where do the points that are true have to be? On the other side.
Yep.
So if it's false, you shade the other side. If it's true, you shade that side. So we're going to lightly with our pencils color over here. Yeah, you did. And mine likes to, when I scribble, it likes to make it disappear, so I got to go back and do mine.
I wish we had some crayons.
I have some, but we can do it with your homework. We can do them later. I got colored pencils you can use later for your homework. So if it's true, you shade that side with your test point. If it's false, you shade the other side. Okay? Let's try another one. Let's do y is a less than negative 3 over 2 x plus 2. Is it in slope-intercept form?
Yep.
Are we going to use a solid or a dotted line?
Dotted.
Dotted, very good. Okay. All right. What's our y-intercept? 2. So put that on the y-axis. What's our slope?
-3 over 2.
So I go down 3 into the right 2. And we set a dotted line. And again, don't make no little short line. Make your line go as big as your graph does. And remember, for inequalities, we're not done. After we graph a line, we have to check a test point and shade a region. So what do y'all want to use for your test point? 0, 0. Yeah? It don't matter. You can pick a lot of other points as long as it's not on the boundary. So we're going to have 0 is less than -3 over 2 times 0 plus 2. I scrunched mine, I'm sorry. That makes 0, and 0 plus 2 is 2, right? So 0 is less than 2. True or false? That one is true. So do we shade 0, 0, or do we shade the other side? No, we shade 0, 0. Right? Yeah. So you shade it if it's true, shade away from it if it's false. There's some teachers that make students check both regions, okay, and shade the true side. But, I mean, it makes sense. If one of them, if it's not false, it's going to be true on the other side, right? If it's false on one side, it's true on the other side, and vice versa. So I only make people pick one test point. Y'all's graphs are shady. What are you doing?
You had to look at the graph.
It's fine. It's fine. Okay. So let's talk about these little special ones. Lee, settle. Simmer down, child. Okay. Let's talk about these special ones. X and a number and Y is a number. And we talked about one of these when we went over homework. So X is greater than 2. Now, if we just have X and a number and Y and a number, you don't have to worry about slope-intercept form. Can y'all tell me what kind of line this is, horizontal or vertical? It's vertical because it crosses which axis? Which axis? The x-axis, right? So we go the x-axis at 2, and we're going to put a vertical line through there. Will this one be solid or dotted? Dotted, so don't forget to check for that. And then again, we test with a test point. I'm gonna use 0, 0 because it's easy. And the special thing about this one is you only have to plug in the x because that's the only variable you got. So 0 is greater than 2. True or false?
It's false.
That's false.
I hope 0 ain't bigger than 2.
I'd rather have $2 than $0. Right?
I ain't gonna lie, I'd rather have 2.
You crazy.
I'd rather have 0.
All right. So anyways, I'm going to shade the side away from 0, 0. I wish my computer shaded prettier, but it doesn't. No,
It's pretty enough.
So if we did a vertical one, of course I'm going to throw in a horizontal one for us. Can't let the horizontal guys feel left out. They're not. They're not. So if we have just y in a number, then obviously we're going to be horizontal. And how do I graph this? Yes, I'm going to use a utensil like a pencil. In my case, I'm using a stylus. No. No, I didn't lose it. All right, we're not talking. We're recording right now. Stay straight. All right, so how do I graph a horizontal line?
Straight across.
I know it goes left to right, but how do I know where to put it?
Go to -1.
I go -1 on the y-axis. Very good. Is this one solid or dotted?
Solid.
Solid, because it says or equal to. We're going to check 0, 0, I guess, again. And so that I have 0 is less than or equal to -1. True or false?
True. False.
Can 0 be less than a negative number? No, that one's false. So I shade away from 0, 0. So I shade down here. And my variable's out, and I got to put it back. Here, let me grab you a pencil. Okay. All right, we good with those?
Yes, ma'am.
The last thing I have to show you is when our equations or inequalities are not in slope-intercept form. Do what? Is it? Yeah, you're right, because I did ABCD. You're right, I've only done 4. Thank you.
That's the one thing I can put up.
Okay, so if it's not in slope-intercept form, obviously, before we graph it, we're going to have to do what? Yeah, make it look like y equals mx plus b, except not with equals. Well, first I have to get y by itself, right? So subtract 3x, and that gives me a negative 2y less than or equal to negative 3x, because the x part comes in front with slope-intercept form, plus 6. And then I divide everything by what? Negative 2. And remember from last chapter the rules for inequalities. If we divide everything on both sides by a negative, we have to do what? Flip our symbol, right? So a negative divided by a negative is a positive 3 over 2. And positive 6 divided by negative 2 is negative 3. And now it's in slope-intercept form. So any questions about how we got that in slope-intercept form? Okay. So then you're ready to graph it? So what's our y-intercept?
Now negative 3.
Negative 3. And our slope is?
3, 2.
So up 3 to the right 2.
Yeah.
Is this one supposed to be solid or dotted? Solid. It says or equal to, so solid. And just like earlier, we're going to test with 0, 0. So 0 is greater than or equal to. And you could, honestly, guys, I don't care when you have to get them in slope-intercept form if you plug it into the original inequality or the new one that you got when you put it in slope-intercept form. It's not going to matter. You're both going to get the same result. I'm just going to do that because it's familiar to us. And that gets me 0 minus 3 is negative 3. So 0 is greater than or equal to negative 3. True or false? That's true. So we do shade over here where 0, 0 is this time. Mine disappeared and I got to put it back.
I like this a little bit.
You like coloring?
Yeah, I like this too. I know how to do this.
Y'all want to see one more like that, or you think you got it?
Let's do the one more.
Let's do one more. If you've got it, you don't have to. Y'all want to just watch me and not copy this time?
Yeah, okay.
Well, if you want to write it, you can. But I'm just saying maybe it'll help you to just watch for a second. All right. So for this one, what do we have to do first? All right. So how do I get this in slope-intercept form?
Both sides.
Yep. Subtract 3x on both sides. So 4y is greater than negative 3x plus 8. Then what? Divide everything by 4. Do I have to flip the symbol this time? No, because it wasn't negative. So y is greater than x plus what? Mm-hmm. So now we're in slope-intercept form. So what's my y-intercept? 2. What's my slope? Down 3, right 4. Solid line or dotted line? Dotted. I made a fat graph there. And I'm going to test 0, 0. 0 is greater than -3 times 0 plus 2. So 0 is greater than 2. True or false? That's false. So I do not shade where 0, 0 is. I shade away from it. And mine went away, and I put it back. Does anybody have any questions on these? Y'all think y'all can do these on your own?
Yes, ma'am.
Okay. So that is the end of today's lesson.